Okay, so now we're going to talk about another aspect of our debugging. We're going to talk about Thread Sanitizer. So earlier we definitely had some lessons where we dealt with things like queues and threadings and synchronous versus asynchronous um and serial versus concurrent, right? So all this stuff is kind of in the dispatch queue lessons, right? So now what we're gonna do is um I've set up a project that will allow us to run say a pretty intensive task, and it will display that amount here, right? And but the reality is sometimes you get in situations where you run a certain process, and that process takes place on multiple queues. Then there can be confusion about what's running where, and the output, because things are running on different queues. The output can cause uh, the process can cause a bad output. So let's go ahead and touch this real quick, okay? So basically, what I'm going to do is I'm going to basically click this button, and what I'm doing is I'm just creating an arbitrary process. It doesn't really do anything real, right? I loop through all the numbers up to 1,000, 0 up to 999, and I add them all together. And I'm going to print the output there, right? Very simple procedure. So this is what I'm going to say. I'm going to say for item in 0 dot dot under 1,000, right? And we're going to have a variable called compute nums, right? Okay, and we say compute nums dot append item, right? And once we've appended all of these, then we want to add all of them together, right? So I have a function. Give me a second. I have a function that waits till all of these are done and then reduces it, right? I mean, I could just have it add item, but I'm not doing that. I'm just going to reduce it, okay? Grab some water. So what I'm going to do is say, now after all this is done, I'm going to say amount label dot text equals compute num, right? Compute nums dot reduce 0, right? $0 plus $1. Okay. Right. Okay. And that should do that, right? And we should have kind of sign type. Oh, of course I can, right? So I have to cast this as a string. So basically what I'm going to do this. Now I can do that, and then I'm going to go ahead and escape it. Interpolation, right? And there we go. This should be yes. So now Should be able to go ahead and replace this. Right? And of course, and that's the sum of everything add up, 4,950. Now, simple enough. Now I want you to use your imagination a little bit and pretend that, we had a bigger process and things had to take place. You had to have certain things taking place on different queues, right? Right? So, and of course, everything looks good. Nothing's broken, right? No crashes, right? So this is where the thread sanitizer comes in, right? So var, because we want to check to make sure, things are looking good. This is just another tool. Dispatch queue dot, and I'm going to call this thread sanitizer Norbert. Right? So I have this right here, and then I'm going to say queue dot async. Right? Right. Q. Oh, there's something. Oh, yes, that's the reason why it's not working. There should be a label. That right there. Yes. Q dot async, right? And I'm going to put this in here. Put Q dot async, right? X. And of course, self. Now, let's do this. I'm going to run this. Right? And this is 0 because we're getting a funky error. Oh, by the way, let me just do something real quick too, just to make something else clear. So when we run this, because just for experimental purposes, I want to show you something. When we run this, right, and we get the right number, if we keep doing it, see how it keeps adding up. So what we want to do now is, so we don't have to worry about so many things taking place, I'm gonna say compute nums, COM, compute nums, equals an empty array of integer. And so that sets it back to 0 so that whenever I run it, I don't have to worry about, okay, there we go. However, let's go back here. Right? Now that we do this, you see I'm getting these different numbers here, right? It's not working for me. Give me a minute. So the reason why we're getting this error is because things are taking place on different queues. Well, we don't know that. We can assume that maybe there's something wrong with our calculation. Of course, we see this right here, right? And so we know that no, there's nothing wrong with the calculation. What could be going on? Well, we want to rule out problems with queues and threading. And that's where using the thread sanitizer comes into play. So now I'm going to use a thread sanitizer and let's see what's going on, right? I'm going to go here. And not just that, but let's put this on the main queue, right? Put this on the main queue. Dispatch queue dot main. dot async, right? X V, right? And of course, this has to be self dot, right? And I also wouldn't be surprised if self dot so that's on the main queue, right? So if we want to rule this out, let's go right here, and this will tell us edit scheme, right? And run diagnostics. So I went here, I opened this up, I went to run diagnostics, Thread Sanitizer, close, I'm running it, right? Now, again, this might work sometimes. It might not work all the time, but you got to keep running it. That's the reason why I put this zero out functionality down here. So we're gonna run, okay. And because we have the system set up to check out issues with threading, let's see what this says. Okay, previous write on main thread, warning, Thread Sanitizer, Swift access race. What does that mean? That means a race condition is taking place. So what a race condition means is that there is a situation where different things are not taking place the way that maybe they would normally do from top to bottom. You know, some things are finishing earlier than other things, and they're interfering with this coming out. So, for example, this for item in 0 to 100 might be finishing after this starts to reduce. You know, as a result, it creates problems. You know, Thread Sanitizer is used to validate, yes, race conditions are taking place. So, and that in the short skinny is why you would use the Thread Sanitizer. If you suspect that there are race conditions taking place because of the way you set up your dispatch queue, then you can validate it using the Thread Sanitizer. You know, if since this is the case, what we want to do is maybe we want to take this X, put this in here, right? And let's see, of course, self dot. So now I've come back here and I've commented out the main queue functionality. And so now all of this is on the same queue and it's running asynchronously, right? So let's see how this works. So we're here. Thread Sanitizer is still working, right? But we still have problems, right? No, the way to clear this out is, you know, I hate to say we need to do this the old fashioned way. And that is there is no need for the dispatch queue, right? When we run this right here, oh, actually, this needs to be there because this needs to happen before this, and get rid of this, and let's see how this works, right? UI label must be used on the main thread only. Okay, something failed. Extemporaneous. right? I believe this is the extemporaneous one out here, right? And of course, that works. So, yeah, just kind of giving you guys a heads up on how this would work. But yes, a thread sanitizer is used to validate that, yes, maybe there are thread issues in our situation, race conditions. So, of course, there's a lot more to the thread sanitizer, and maybe I'll do other tutorials or lessons about it. But for now, we're on to the next because we still have a lot to cover. So